questions on your homework?
Number 13.
Y equals 3 to the cosecant x. Alright, so what is the derivative of y equals a to the u?
A to the u times, times d u.
Okay, so what's my e to the u, a to the u here?
3 to the cosecant x.
Times my derivative of cosecant, what's the derivative of cosecant?
-1 over this absolute value of u times the square root.
No.
Isn't it AU, ln A, du?
What? I don't know.
You will use the second one.
Yeah, this is e to the x. E to the u. So a to the u is a to the u ln a
Du.
du.
Oh, yeah, okay, that's what I had on my paper.
Alright,
I don't know what I was thinking.
so we got 3 cosecant x, then we have ln of
3.
3 times the derivative of cosecant x.
Yeah, wouldn't that be -1 over the absolute?
No, what's the derivative of cosecant?
Oh, I was thinking of arc cosecant.
Yes. Negative cosecant x cotangent
Okay,
x.
that's why. Okay, thank you.
We get negative
I figured that.
ln 3 times 3 cosecant x times cosecant x cotangent x. I got it wrong. Okay. Anything else?
Yeah.
Alright, 45 we'll come back to because I really did teach that yesterday. I didn't get to that yesterday, so we'll look at it today.
Okay. And 29.
Y equals 3 to the x plus 1. Y equals 3 to the x plus 1. 3 to x plus 1. Alright, so we're going to take the derivative. So y prime equals 3 to the x ln 3. Correct?
Yeah.
Alright, so we want that, what is the point on the graph that is tangent line parallel to the line y equals 5 to the x, or 5x? So we need this 3 to the x times ln 3 to equal 5. Alright, so how are we gonna solve for x here?
You make it equal to the slope.
What's that?
You just make it equal to the
Mhm.
slope of
if we get rid of ln 3,
Hey, where did you get 5 from?
slope of the line.
Okay.
Alright, so now how are we gonna solve for x?
Log,
Alright,
both sides.
so we're gonna have x equals 5 over ln 3 divided by ln 3, correct?
What did you,
No, just take that back, sorry. So we're gonna have x ln 3 equals ln of 5 over ln 3. And then we divide by ln 3.
okay.
So take the ln of 5 over ln 3 equals, divide by ln 3, and we get what?
I got
379.
1.379.
So we have 1.379, you said?
Yes.
Alright, so how do I find my y?
Put it back in.
Plug it back into this equation here.
Mhm.
So we take 3 to the 1.379 and add 1 to it.
$5.549.
So that's where the tangent line is parallel to the line y equals 5x plus 1. Any other questions? Everybody good? Grace, you good? Alright. I will take those. Let's look at logarithmic differentiation. Let's just take y equals sin x dx. So here we got y equals sin x to the x. So sometimes it's easy to use logarithmic differentiation. So what we're going to do, we're going to take the logarithm of both sides. Ln y equals x ln of sin x. So we're going to take the derivative of both sides. So ln y, derivative of ln y is 1 over y dy. I'm going to put this over some so I don't run out of room. 1 over y dy. Here we got a product. We got x ln sin x. So it's going to be the first times the derivative of the second, which is
1 over sin x.
1 over sin x times
Times
cosine x plus ln of sine x times derivative of x, which is
1.
1. And this is all going to be dx. So if we simplify this, 1 over y dy equals x cotangent x. Because cosine over sine is
Cotangent.
cotangent plus ln of sine x dx. So bring the dx over, so I get dy over dx. Take the y over, y times x cotangent x plus ln of sine x. And again, same thing before, we only want one variable, we don't want the y, so what does y equal? Sine x to the x. Times x cotangent x plus ln sine x. Which will be my derivative. Let's look at 45. All right, so we're going to use logarithmic differentiation because it could get quite confusing here. First of all, though, I want to change this equals x minus 3 to the 4th times x plus 1 over 2x plus 5 cubed all to the 1/5. And then I'm going to take that and apply that 1/5 to all the exponents. This is going to be x minus 3 to the 4/5. This should be x squared plus 1. X squared plus 1 to the 1/5 all over 2x plus 5 to the 3/5. That makes sense to everyone? Just using our exponential rules. Logarithmic differentiation tells me to take the logarithm of both sides. Ln of y equals ln of x minus 3 to the 4/5 times x squared plus 1 to the 1/5 all over 2x plus 5 to the 3/5. So far, so good? Now I'm going to use my principles of logarithms to expand that. That's going to be ln of y equals ln of x minus 3 to the 4/5 plus x squared plus 1 to the 1, let's put up the log. Ln of x squared plus 1 to the 1/5 minus ln of 2x plus 5 to the 3/5. So all I did is use my principle of logarithms. If I'm multiplying, it's going to be plus. If I'm dividing, it's going to be minus. I can expand my logarithms like we learned back in pre-calculus, back in the beginning of the year. Now I can take my derivatives. Derivative ln y dy. Derivative of ln of 4/5 to the x minus 3. Well, first thing I think of, I'm going to bring the 4/5 to the front. Now take the logarithm of, or the derivative of the logarithm of x minus 3, which would be 1 over x minus 3, right? Times the 4/5.
Wouldn't it? Oh.
This would be 4/5
Yeah.
times 1 over x minus 3. Correct? Same thing here. Plus, this is going to be 2x over x squared plus 1.
Got 2x.
I got 5. Because again, we got a composite here, so it's going to be 1/5 times 1 over x squared plus 1 times the derivative of the inside, which is 2x.
That first one, the 4 over 5 x minus 3,
Uh-huh.
would that be to the negative fifth or negative 1/5?
No. Remember, the 4/5 is in front, so now we got 4/5 ln of x minus 3. So we're just taking the derivative of this, which ln over u is 1 over u du. So it's 1 over x minus 3 times the derivative of x minus 3. Then times the 4/5. And then this would be minus 6 over 2x plus 5 times 5.
Times 4. Oh, what's that?
Again, this is 3/5
Yeah.
times 1 over 2x plus 5 times 2. And remember, this is all dx. Divide by dx, dy over dx equals y times 4 over 5 times x minus 3 plus 2x over 5 times x squared plus 1 minus 6 over 5 times 2x plus 5. Then what does y equal? Right there. And that's my derivative.
Would this be on the test?
Yes.
Would you want us to simplify the denominator, like distribute
No.
by? No?
Nope.
Okay.
Create as less work as possible for you. And again, it's not that difficult, it's just tedious. Right? You just have to be careful, stay neat, stay concise, stay focused, and we use a bunch of principles here. We use principle of logarithms, taking a logarithm on both sides, principle of logarithms, how to expand our logarithms, and then our principle of derivatives of our logarithms. Okay? Any other questions on that? And you'll be able to practice a little bit. You have a couple to practice on this weekend. All right, let's look at some of our logistics. Let's look at number 52. The spread of the flu in a certain school is modeled by the equation PT equals 200 over 1 plus e to the 5 minus t, where PT is the total number of students infected T days after the flu first started to spread. Letter A. Estimate the initial number of students infected with this flu. Initial means what? Time is? Time is 0. So we would put 0 in for our T, right, and evaluate. That's 200 over 1 plus e to the 5th. Because 5 plus 0 is 5. So I just plug this into my calculator. All right, so approximately, because we're estimating, so we want to round off. 1 student, right? Letter B. How fast is this flu spreading after 4 days? Well, if we're talking about fast, we're talking about what?
What? Would it be rate of change?
Rate of change, correct.
Okay.
Rate of change means what?
Is how many people are getting infected?
But what does rate of change mean?
Oh, it's the derivative.
It's the derivative. So we want to take the derivative of this. Which if we take the derivative of this, that's going to be, how do you want to take the derivative?
I would probably do the quotient.
Quotient rule, so low, times the derivative of the top, which is
0.
0, minus the top, times the derivative of the bottom,
It would be e to the 5th minus t times -1.
everybody agree? All over squared, correct? If we simplify this, this disappears. So it's 200 e to the 5 minus t over 1 plus e to the 5 minus t squared. We want to find out the rate after 4 days. So we put 4 in. So it's going to be 200 e to the 5th over 1 plus e to the 5th squared.
Well, how would it be e to the?
I'm sorry, e to the 1st. Thank you. Caught that just as you're starting to say something. So we plug in our calculator, 1 plus e equals squared equals, and divide that into 200e. So again, we're estimating, we can't have part of a student, so we round off to 39 students per day. So you can see how fast the spread happens. So they're kind of applicable to today with the coronavirus and stuff. You know, we start out with one student, then after 4 days, what do we have? We got 39 students per day.
That would be bad.
Yeah, it spreads fast. All right, next question says, when will the flu spread at its maximum rate, and what is that maximum rate? Now remember, 200 over 1 plus e to the 5 minus t is what type of a function?
Is it does this the yeah that's what I was
The logistic function? Alright, so normally my normal logistic function, here's where it is spreading the fastest. But this function here, what had happened to this function? What was the transformation of this function?
it's
One to the right, or left?
Went to the right, how far?
Is it to the right or left?
Well, again, you got 5 minus t, so what did we do to the t there?
Oh,
negative the t.
Okay?
And you went to the
So
left.
yeah,
You went to left
left
5.
Wait, no, because if you take the negative out, that's 2 minus 5. So right
What's the
5.
right
Went to the right 5.
Okay.
So therefore, where is it going, where is the slope the greatest now?
At 5.
At 5. Okay, so we come back to my rate function here and put 5 in. So 5 minus 5t, that e is going to be 1, that's 200 over 1 plus 1,
2.
2 squared,
So 50.
50 students per day is when the rate goes the fastest. All right, so that's how we're doing those type of problems there. Any questions on that, what we did? Remember, anytime they say how fast, we're looking for rate, and when we look for rate, we're looking for derivative. So that's why we had to take the derivative. Quotient rule is fine, and then plug in the numbers that we need to see. Then we go back, all right, where is it moving the fastest? Here's my normal logistic function. My fastest is usually right there, and just figure out which direction this graph moved. And that will tell you when it's moving the fastest. So that's why we got to 5 because of this. We take out the minus. We get t minus 5. Okay? And so therefore, we move to the right 5 places. Any questions on that? Grace, we're good? You clear? Noah? Kim? Allie, we good? All right. So this weekend, what you're going to do, you're going to do 1 through 53. Or sorry, 3 through 53. Every other odd, and then there is a Math XL. This didn't take you too long last night, did it? Page 178, 3 through 53, every other odd, and Math XL 3.9. Your quiz on all this will be on Tuesday. Alright, so Monday we'll review those 3.5, 3.6, 3.7, 3.8, 3.9. Alright, so that is 3.5 starts out I forgot now.
I think it was,
Trig functions, then we had chain rule, then we had implicit,
and then the arc.
Arc.
then the arc inverse, and then the special derivatives.
So this won't be on the,
What's that?
the logarithmic differentiation won't be.
Yes, it will,
Oh, well.
yes. But your quiz is just, we already did 3.5, 3.6, right?
Mhm.
So it'd just be 3, 7, 3, 8, and 3, 9. Alright, 3, 7, 3, 8, and 3, 9.
Do you want that 4 through, or page 174 through 28 for the extra credit or whatever you said?
Yes, if you have it. Page 174 to 28, one for the 4? Yes.